Good morning to everyone. I hope the test was okay. If you found the test to be very tough, don't worry about it. थोड़ा सा और practice करना पड़ेगा. So I'm starting with the most important. I'm starting with the most important part of this course. Now, whatever I'm going to teach you for the next 4 or 5 lectures will stay with us for a long time till the end of the course. The reason is that irrespective of the topic, ultimately what you want to do is you want to predict how the particle will move. Okay, so if we want to talk about, let's say, uh, heat and thermodynamics, right, then you will find that we want to predict how the individual molecules will move. We can't actually do that, but we can then define a average behavior. If you talk about electricity, we want to define or we want to find, we want to predict how the charges will move in the presence of other charges. If you think about magnetism, we want to define, we want to predict how a magnet will move in the presence of other magnets. Fluid mechanics, how an object will move if it is surrounded by fluids. All of these questions are answered by Newton's laws of motion, right? So that is why we consider Newton to be one of the greatest contributors to physics, because it is this framework that I'm going to teach you, it is this set of rules that I'm going to teach you, will be used to predict the motion of uh, objects in various cases, in various scenarios. Newton himself used this to predict the motion of to predict the motion of various planets and to predict when the next solar eclipse will occur or when the next lunar eclipse will occur. And of course, his predictions were absolutely spot on every time. So he could actually predict when the next occurrence of or the next sighting of Halley's comet would be there, right? So, and on that day, uh, when people looked up in the sky, they saw Halley's comet. So that is the power of prediction. That is the power of the laws of physics, right? Unfortunately, there was one planet which did not obey Newton's laws. Can anyone guess which planet this was? Can anyone guess which planet this was? प्लूटो तब तक डिस्कवर नहीं हुआ था मेरे भाई. So the planet which did not which did not conform to Newton's laws was Mercury, and it was in 1915. Okay, now remember that Newton was there in 1600s, and it was in 1915 that Einstein came up with his relativity, theory of general relativity, that predicted how Mercury would move. The prediction of Newton and the prediction of Einstein were different by a very, very small amount. It was different by such a small amount that to observe this difference, uh, during a particular solar eclipse, you actually had to go near the North Pole and see Mercury to measure this minute difference between the prediction of Newton and the prediction of Einstein. And if you read the story, it's very fascinating. So there was an expedition in the 1920s, I believe. They went to the North Pole. There was going to be a full solar eclipse, and they actually saw Mercury from there. They measured the movement of Mercury from there, and they found that it is exactly as Einstein has predicted. And that is when the theory of general relativity was accepted as superior to Newton's theory, right? Which we are going to study. We are going to eventually study. So Newton gave two different theories. One is the theory of motion, which is Newton's laws, the three laws, and the other is the law of universal gravitation. So we are going to study gravitation later on, and we are going to study Newton's laws, the three laws of motion now. And I would like you to sort of open your minds in the sense that अभी तक आपकी जो भी पढ़ाई होती है वो मेरे को ऐसा लगता है that in your minds the studies are compartmentalized. Okay? Now this is valid for maths, sort of valid for maths, and valid for chemistry. So for example, if you are studying organic chemistry, then uh, gaseous laws or chemistry of gases has got very little to do with organic chemistry. So these are two independent topics that you can study without knowing the other. You can study organic chemistry without really having an in-depth knowledge of gaseous laws. Unfortunately, in physics, it does not work that way. Okay, so whatever we have discussed up till now, that is not going to be independent of what we are going to discuss later on. And what we are going to discuss later on is not going to be independent of what we have already discussed. So in physics, whatever I teach, it has to be taken as a global set of concepts. So अगर मैंने आपको न्यूटन्स लॉज ऑफ मोशन पढ़ाया और हम उसके बाद से इलेक्ट्रिसिटी पढ़ रहे हैं, तो इसका मतलब ये नहीं है कि इलेक्ट्रिसिटी में आप न्यूटन्स लॉज ऑफ मोशन भूल जाएं. In fact, the reason why I can't teach you electricity today is that you don't know Newton's laws of motion. In fact, when I teach you Newton's laws of motion, when I teach you work, power, energy, when I teach you the concept of center of mass, when I teach you rigid body dynamics, when all these topics have been taught or at least introduced, then we talk about the other aspects of physics. Having said this, some topics in physics are uh, partially independent, partially compartmentalized. For example, optics. Optics में mechanics के बहुत ही कम concepts आने वाले हैं. Heat and thermodynamics थोड़ा बहुत, but without learning mechanics, it is very difficult for you to understand heat and thermodynamics. So what I'm trying to say is that if I have taught you kinematics and I'm going to teach you Newton's laws of motion, please do not for a moment think that kinematics की requirement अब खत्म हो चुकी है और अब जो सर ये पढ़ा रहे हैं अब मेरे को अच्छे से बस इसको पढ़ना, अच्छे से इसको तो पढ़ना ही पढ़ना है. But what is going to happen is that the concepts of kinematics are going to be used. So whatever question I give will involve Newton's laws of motion and the concept of kinematics. Of course, the silver lining in the cloud is that when kinematics is used in Newton's laws of motion, it will be of a very, very basic level, right? And similarly, when Newton's laws of motion is used in future topics, then the level of the application of Newton's laws will be very, very basic. अगर मैं इलेक्ट्रिसिटी में आपसे न्यूटन्स लॉज अप्लाई करवा रहा हूँ तो it will be the minor application. The major application, of course, will be the laws of electricity. And this is why questions become tough for you, okay? Because of the fact that I am going to build up concept upon concept upon concept, and ultimately what is going to happen is that I am going to give you a question which will demand the application of multiple concepts, multiple chapters. Right? So when we study the concept of center of mass, okay, I am going to say कि मैंने एक बुलेट फायर किया गन से, अब ये बुलेट प्रोजेक्टाइल की तरह ट्रैवल करती है और एक ऑब्जेक्ट को हिट करती है. जब उस ऑब्जेक्ट को हिट करती है तो वो ऑब्जेक्ट मूव करना शुरू करता है और थोड़ी देर बाद रुक जाता है. So please tell me, when will it stop? Right. So first thing, you have to use the concept of projectile motion to predict what will be the horizontal component of velocity of the projectile when it hits the object. Then using the horizontal component of the projectile, you are going to apply the law of conservation of momentum to find what is going to be the velocity of the object after the collision with the projectile has occurred. And then you are going to apply the concepts of friction, and you are going to apply the concept of kinematics to find कि उसका acceleration क्या है और वो कितने समय बाद उसकी velocity zero हो जाएगी. अगर ये acceleration constant आया तो you will be using s is equal to ut plus half at square, v is equal to u plus at. अगर ये acceleration variable आया तो जैसे हमने variable acceleration के problems को solve किया था using calculus, then you will be using calculus at that point of time. But if you falter, if you do not remember, if you are unable to apply any of these three separate concepts, projectile motion separate, idea of collision separate, Newton's laws of motion to find the acceleration of the object after the collision separate. After having found the acceleration, then finding the time in which the velocity will become zero separate. Okay. So these are the sets of conditions, or these are the sets of laws, numerical methods that you have to apply on a problem simultaneously, which makes a question tough. अब हम प्रोजेक्टाइल भूल गए. अब जब प्रोजेक्टाइल भूल गए तो फिर वो गन का जो बुलेट है या कैनन बॉल है, जब उसने हिट किया ऑब्जेक्ट को तो क्या होगा. कंजर्वेशन ऑफ मोमेंटम तो याद है, लेकिन जब वेलोसिटी नहीं निकाल पा रहे हैं हम इनिशियल, तो कंजर्वेशन ऑफ मोमेंटम भी अप्लाई नहीं कर पाएंगे. राइट. सो इट इज अ चेन ऑफ इवेंट्स which we have to analyze, and each link in the chain requires the application of separate concepts of physics. So the concepts of kinematics that we have learned is very, very important and is going to be constantly applied in the problems that you will see. Similarly, the concepts of Newton's laws of motion that we are going to discuss, right, will be again a universal एप्लीकेशन। तो ये भी अच्छे से सीखना है, काइनेमेटिक्स भी अच्छे से सीखना है, और इसके बाद जो अपन सिखाएंगे वर्क पावर एनर्जी वो भी सीखना है। उसके बाद से उनको सेंटर ऑफ मास का कॉन्सेप्ट आएगा, वो भी अच्छे से सीखना है ना। सो यू हैव टू हैव ए ग्रास्प ऑफ दीज इंडिविजुअल टॉपिक्स सेपरेटली। अगर सिर्फ काइनेमैटिक्स का क्वेश्चन मैं पूछूंगा तो वो थोड़ा सा डेप्थ में पूछूंगा। अगर मैं सिर्फ न्यूटन्स लॉज ऑफ मोशन का क्वेश्चन पूछूंगा तो वो थोड़ा डेप्थ में रहेगा। बट जब ये कॉन्सेप्ट्स एक साथ अप्लाई होंगे, सो यू कैन बी रेस्ट अश्योर्ड दैट इन न्यूटन्स लॉज ऑफ मोशन 90% of the cases will be of constant acceleration. Only 10% of the questions will be that of variable acceleration, right? और ये वेरिएबल एक्सेलरेशन वाले प्रॉब्लम्स हम बिल्कुल एंड में करेंगे एनएलएम के, न्यूटन्स लॉज ऑफ मोशन। अभी आई वांट टू टीच यू न्यूटन्स लॉज ऑफ मोशन, राइट, व्हिच यू ऑलरेडी have some knowledge of, but I want to teach you from level 0, because I am going to approach the concept of Newton's laws of motion in a different manner, right? Okay, so it is very important that you listen to what I'm saying. Okay, stop typing, listen to what I'm saying. So there are 3 laws of Newton. 1, 2, 3. I am going to discuss these 3 laws one by one. And let me assure you that the first law is the most important law. Okay, the first law is the most important law. In fact, these 3 laws are given in terms of importance. First law सबसे important, फिर second law, फिर third law. Application तीनों का simultaneously होएगा, लेकिन importance सबसे पहले first की है, फिर second की है, फिर third. Now the first law tells us that an object in an object at rest will remain at rest, and an object in motion will remain in motion unless and until acted upon by an external force, right? So first let me tell you why this पार्थ मैं बोल रहा हूँ ना, टाइप मत करना, टाइप करने की कोई जरूरत नहीं है, मेरे को बताने की जरूरत नहीं है कि ये लॉ ऑफ इनर्शिया, आई नो. So first you must understand that whatever Newton has said, okay, is a watertight definition of certain things which we are not going to discuss. What I want to do is I want to rephrase the first law so that we can apply this first law and solve numerical problems, okay, and solve practical problems. So the first law tells us that an object will remain in its state of rest or motion unless and until acted upon by an external force. Now, I think I have had this discussion before, but I will say it once again briefly, that the statement itself is absolutely genius, and it requires an intellectual leap which is huge. Because remember, I told you that for the past 2000 years, 2500 years before Newton, the law of Aristotle was prevalent, which told us that a force is required to maintain the velocity of an object, which of course Aristotle got from daily experience. अगर हम एक चेयर को मूव कर रहे हैं तो उस चेयर को कांस्टेंट वेलोसिटी से मूव करने के लिए हमको उसके ऊपर फोर्स कॉन्स्टेंटली लगाना होता है. अगर हम चेयर पे फोर्स लगाना बंद कर देंगे तो इवेंचुअली चेयर का मोशन खत्म हो जाएगा. So Aristotle thought that this concept of force, that this push or pull is required to maintain velocity. It was Newton who first realized that it is not the maintenance of velocity which requires force, but the maintenance of acceleration which requires force. So a net force on an object, and the word net is very important, which you'll see later on. So a net force on the object must result in the acceleration of the object, and acceleration of the object means that the velocity of the object will change with time. Therefore, the statement an object will continue to be in its state of rest or motion, that means that the velocity of the object will never, ever, ever change unless and until the object is acted upon by an external force. Okay. Now the word external is also very important. What do I mean by these two words, external and net? Okay. I think I've discussed what is the meaning of force previously. Force is simply the cause which results in the effect of acceleration. So if around you, you are to observe an object whose velocity is changing with time, then you can immediately come to a conclusion that there must be a net force acting on this object. Okay. So let me first clarify what I mean by net and what I mean by external. So when I say net, I mean that it may be that multiple forces are acting on the object. Okay? Multiple forces are acting on the object. I'm going to call the object the system. And I'll tell you what is the definition of the system after I tell you the meaning of the net force. So if multiple forces are acting on the system, then the net force is the vector sum of these forces, right? So net force is the vector sum of all the forces acting on the system. Multiple forces may be acting on the system. How is it that multiple force will act on the system? Well, to tell you that, I must first tell you what is the meaning of system and what is the meaning of external. Okay? Net का मतलब vector sum. So we have a road, and on this road we have I don't know, a bus like so, and on this bus we have a person like this. What do I mean by a system? Well, a system is basically a boundary or the internal contents of a boundary which have been drawn by an observer. This boundary is, of course, imaginary. It does not exist physically. It exists only in the mind of the observer. So observer one may come along and say that this is the system. Observer 2 may come along and say that this is the system. Observer 3 may come along and say that this is the system. Okay. So different observers are going to draw different boundaries. Whatever boundary is drawn, The object inside or the objects inside constitute the system. Anything outside the boundary is called the external object. So, for example, for this observer, black observer, the system is equal to the man and the external object is equal to the bus. Okay? For this observer, the red wala observer, the system consists of the man plus the bus, and the external object is the ground or the road, right? For both, the external object is the earth as well, right? The earth, the planet earth, which exists below. So for both of them, you have earth as an object in the system. For this guy, the yellow guy, the system is the tire. Okay? The system is the tire. And the external object is anything which is external to the tire. That means the axle of the bus, the body of the bus, the man, the earth, the air outside, whatever, everything outside the yellow boundary is the external object. Anything within the yellow boundary is the system that the person has chosen, right? So, what is the system? System is a set of objects or object which has been chosen by the observer to constitute the system, right? Now, you will be, तरुण मैं क्या बोल रहा हूं अभी कुछ टाइप नहीं करना है ठीक है ना सुनाई दे रहा है ना ये you can hear me right so the system is the boundary which has been decided by the observer okay anything external any object external to the boundary that the observer has drawn will be classified as external to the system. Anything within the boundary will be classified as the system, as a part of the system. Okay, right? So the net force means the vector sum of all the forces acting on the system. The system means a boundary or the internal contents of a boundary that has been drawn by an observer. Now, of course, the question must arise in your minds, what if there are 10 different observers? जैसे यहाँ पे मैंने दिखाया 3 different observers. What if there are 10 different observers and all 10 of them decide to have 10 different systems? Well, then all 10 of them will have 10 different systems. For all 10 of them, the list of external objects will be different as it is here for the 3 observers, right? What is going to happen then is that in our perfect Aristotelian world, we are going to have extremely simple systems and objects. So generally, I'm going to give you a problem like this, that there is a block of mass m which is under the influence of a force F, which is acting at an angle of theta. What is the acceleration of the block, right? So such a question comes along, such a practical problem comes in front of you, such a model comes in front of you, and you are 10 people sitting in my class, then I will expect that the choice of the system will be a logical one. फॉर एग्जाम्पल यहाँ पे अगर ये ब्लॉक है तो ये हमारा सिस्टम होना चाहिए राइट एंड रिमेंबर दैट सिंस वी आर टॉकिंग अबाउट द perfect hypothetical world in which everything for us is simple, that means that all complications of real life have been removed. Therefore, in this world for us, there will be no air, there will be no variation of gravity. The earth will be a perfect, absolutely perfect sphere. Okay? There will be no friction to begin with. Friction is so important that we have a separate chapter dedicated to it. So when I'm teaching you Newton's laws of motion, I have even gotten rid of the concept of friction, right? So in this ideal world of ours, you will have no friction, no air, no uh, complicated mechanisms. So even if I tell you that a car or a bus is moving on a road, you will consider, just like in kinematics, the car and the bus to be devoid of any internal mechanism, and you will treat the car or the bus as a point particle. If we talk about the person inside the car, then again, the person inside the car will be treated as a point particle. So in our studies, you will find, we will find that the choice of the system is not ambiguous in any way. It is very clear. Okay? And therefore, I don't want to see you making stupid choices of systems. So here, if I am asking you some question about the man, then the man will be the system. If I'm asking you some question about the bus, then the whole bus plus the man will be the system. Never ever will the tire be the system. Okay? Unless, of course, it is specifically asked for in the question. So although I am saying that the system is a choice that the observer is making, the problems that we will be seeing, there will be no ambiguity in the choice of the system. As we move along, as we come to face more and more complicated problems, it may happen that you may have to choose, or your choice of system may be multiple. That means that ऐसा हो सकता है और ऐसा होगा कि आपको एक प्रॉब्लम में 3 ऑब्जेक्ट्स दिए गए हैं. So you may have to choose the system as the individual objects, or you may have to choose the system as the whole. Right? I'll give you an example. So if I were to discuss, which I will at some point of time, if I were to discuss a question like this, that there is a wedge of mass m, and on this wedge there is a block of mass m1, which is connected by a string to a pulley, and on the other side of the pulley there is a block of mass m2, right? So in this case, the system, the choice of system will be more than one. So you will choose different systems at different stages of solving the problem. So you will choose the system as M1 and you will analyze the motion of M1. You will choose the system as M2 and you will analyze the motion of M2. You will choose the system as capital M and you will analyze the motion of capital M. It may happen that you may have to choose the system as the collective M1, M2, and M. And I will make it very clear when and how to choose a system which consists of more than one object. Okay, so for now, all the systems will consist of one object. I will tell you when you can choose a system which consists of more than one object. Okay, so this is the definition of the system. What do I mean by external? Right? Anything outside the system is external. Now let's come to the first law of Newton. So the first law of Newton tells me, जो statement है Newton's laws का वो तो है ही है. Of course, that is much more superior to what I am going to say. But what I am going to say will be helpful for us in application of Newton's law. Okay, so please listen to me very carefully. और ये जो मैं सेंटेंस बोल रहा हूँ इसको बिल्कुल गांठ बांध के अपने दिमाग में आपको रखना है. So the first law tells us that a system will experience a force due to all objects in its surrounding. Okay? Or you can say due to all external objects. Right? Very, very important. Let me tell you what is the meaning of this statement. सब लोग, all of you, right? Keep your pen on the table. Remove your hand, no contact with the pen. You are just keeping the pen on the table, or at least you are observing a pen which is kept on the table. So if there is a pen which is kept on the table and I tell you that the pen is the system, right? So this is the table and this is the pen, and I'm telling you that the pen is the system. Then what are the objects which are external to the system? So in our minds, we draw a boundary. It has to be a three-dimensional boundary, of course. हाँ, बिल्कुल सही. It has to be a three-dimensional boundary, completely envelops the pen. Shape of the boundary is exactly the same as the shape, the external shape of the pen. Now, what are the things which are external to it? The best part of application of Newton's laws is that you don't have to think. You only have to observe. Okay? It is unlike what we have done in kinematics where some thought was required. कैसे मूव करेगा पार्टिकल. इक्वेशन दे दिया मैंने, x is equal to t square minus 5t plus 6 and I leave it to you to imagine भाई t चेंज होएगा तो x कैसे चेंज होएगा. यहाँ पे ऐसा कुछ नहीं है. यहाँ पे observation matters. Okay? All you have to do is observe and conclude. So for the pen which is kept on the table, what are the objects in the surrounding that you observe? Well, the first thing that you must observe is the surface of the table, right? The pen is kept on the table. So the table must be an external object. Okay, what else? You are an external object. Anything that is there in your room is an external object. Anything that is there in your room is an external object. अगर आपका फैन चल रहा है तो the air which is blowing and hitting the pen, that is an external object. फैन नहीं भी चल रहा है, still the air is an external object. Okay? The light which is hitting the pen, the photons of light which are hitting the pen, external objects. The earth is an external object. The sun, the moon, all the bodies which are in heaven, which are astronomical bodies, all the objects, they are external objects to the pen. And according to the first law, each one of these objects is applying a force on the pen. Now, let us analyze what kind of force these objects are applying on the pen. So you are sitting next to the pen, you are an external object, you are applying a gravitational force on the pen. In fact, I am applying a gravitational force on your pen, right? The value of the gravitational force we can figure out is F is equal to gm1 m2 by r square. And the direction of this gravitational force is towards the mass. So the force that you are applying on your pen is having a magnitude gm1 m2 by r square, and its direction is in a general sort of direction towards you. Exact direction तो हम workout नहीं कर सकते हैं, but general direction towards you. The sun is applying a force on the pen, gm1 m2 by r square, towards the sun, towards the center of the sun. The moon is applying a force on the pen, gm1 m2 by r square, towards the center of the moon. I am applying a force on your pen. The building that I am in is applying a force on your pen. The building that you are in is applying a force on your pen. The other pens which are there on your table are applying a force on your pen. Right? Everything that you observe and everything beyond the four walls of your room, all of these objects are applying a force on the pen. The fan is making the air molecules move, and these air molecules are colliding with your pen, and therefore they are applying a force on your pen. The photons of light are striking your pen, and therefore they are applying the force. They are applying a force on your pen. The surface on which the pen is kept, remember we discussed this in the last class, the surface on which your pen is kept is applying an electrostatic repulsion on the pen. The earth is applying a gravitational force on your pen, right? So Newton's first law tells us that any external object to the system is going to apply a force on that system. If there are no external objects, if there are no external objects for your system, then your system will experience no force. And in this case, the system will continue to be in its state of rest or in its state of motion forever. Okay. So when is an object devoid of, when is a system devoid of external objects? Well, if you keep your pen far away, somewhere very far away in the universe, such that there is no mass in the vicinity of the pen. कोई planets नहीं है, कोई solar system नहीं है, कोई galaxy नहीं है, बिल्कुल कहीं आपने कोने में, universe के किसी कोने में रखा हुआ है पेन को, then that pen will experience no force and it will continue to be in its state of rest or motion. However, in the presence of various external objects, it may happen that the net force is zero. So if there are 10 objects if there are 10 external objects for a chosen system, then according to the first law of Newton, all these 10 objects are applying a force on the system. And it may happen that these 10 vectors may add up to 0. And if this happens, then the net force on the object is 0. And again, this object will continue to be in its state of rest or motion forever and ever. Okay, so please recognize two different scenarios here. Scenario one is that there are no external objects at all for your chosen system. Very rare, very unlikely. In this unlikely situation, the motion of the object, the motion of the system is never going to change. A more likely scenario is that the objects in the environment apply such forces that when we add these forces on the system, we get a net, we get a sum of 0. In this case also, the motion of the system, the velocity of the system will always be maintained, never change. Now, I have told you that we will not be dealing with complications. We will be having a very simple, very simple structure. We will be living in our ideal world of point objects and no complications. Therefore, I will get rid of all complications. Okay, I will get rid of all complications. Therefore, for your pen, there is no air, there is no light, there is no you, there is no I, there is no building, there is nothing else in the vicinity of the pen which has mass. Okay? Even the table on which it is kept, the mass of the table is neglected. Floor is neglected, everything is neglected. And it turns out that in this ideal world of ours, there can only be 5 possible objects in the environment, in the surrounding of a system. Only 5 possible objects. 5 objects in the surrounding, or let me write it as 5 objects external to a system. Number 1, Earth. Number 2, surface. Number 3, string. Number 4, spring. And number 5, an external agent. These are the 5 possible objects which you may find external to a system, external to your chosen system. Out of these 5 possible objects, 4 can only be external to your system if they are in direct contact with your system. So these 4 guys, they must be in direct contact. So what do I mean by each and every one? Let me show you. 5 objects possible: earth, surface, string, spring, external agent. So what do we mean by external agent? पहले ऊपर उल्टा शुरू करते हैं. So if I give you a situation like this where the M mass is being pulled by an external force, और मैंने ये एक्सटर्नल फोर्स के एप्लीकेशन का कोई मैकेनिज्म आपको नहीं बताया, मैंने बस बोला कि इट इज बीइंग पुल्ड बाय एन एक्सटर्नल फोर्स. अ मैन इज पुलिंग ए ब्लॉक लाइक दिस. कैसे पुल कर रहा है ये सब कुछ नहीं बताया आपको. सो इन दिस केस दिस is the external agent. This surface, here we have. Now the way to think about this is that अगर मैंने आपको एक प्रॉब्लम दिया या आपके सामने एक प्रॉब्लम आया जिसमें कि इस ब्लॉक के मोशन का डिस्क्रिप्शन पूछा जा रहा है, तो इन योर माइंड यू विल ड्रॉ दिस ग्रीन बाउंड्री दैट आई हैव ड्रॉन, एंड एनीथिंग touching the boundary, anything breaching the boundary is capable of applying a force on the block. Anything not touching the boundary, anything not breaching the boundary is incapable of applying a force on the system. Right? So let me repeat what I have just said, क्योंकि आप लोग आई एम श्योर ये सब बातें भूल जाओगे. फिर से बोल रहा हूं और ये चीज याद रखनी है, अगर आपके सिस्टम के बाउंड्री को कोई चीज टच कर रही है तभी वो उस सिस्टम के ऊपर फोर्स लगा सकती है. अगर कोई ऑब्जेक्ट आपके सिस्टम के बाउंड्री को टच नहीं कर रहा है तो वो सिस्टम के ऊपर फोर्स नहीं लगा सकता. ओके, the force may only be applied by an external object if the external object is in direct contact with the system. Otherwise, it may not, except one, that is Earth. Earth is capable of applying a force without contact. All you have to do to see that is throw the pen out of your window and the earth will apply a force on your pen. It will make it accelerate without any contact. And this is a fascinating subject in itself. This is a fascinating subject in itself, and we will be dealing with this in class 12th. Okay, अभी नहीं. अगर कोई ऑब्जेक्ट आपके सिस्टम के डायरेक्ट कांटेक्ट में है, कांटेक्ट, तभी वो सिस्टम के ऊपर फोर्स लगा सकता है. अदरवाइज फोर्स वो नहीं लगा सकता है. सो लुकिंग एट दिस सिचुएशन, प्लीज आंसर yes or no. Is M2 applying a force on M1? Please answer yes or no. Is M2 applying a force on M1? Is M2 applying a force on M1? हाँ भाई, रजत, पार्थ, अद्वैत, महक, चैतल, अनीशा, do you think, can you see M2 touching M1? Can you see नहीं, व्हाट डू यू मीन नॉट डायरेक्टली? मैं आपसे अभी बोल रहा हूं डायरेक्ट कांटेक्ट में है तो फोर्स लगा सकता है, नहीं तो नहीं लगा सकता है. इज M2 टचिंग M1? Is M2 touching M1? Is M2 in physical contact with M1? Is M2 drawn here? Is M2 here? Or is M2 here? Is M2 physically separated in space from M1? Or is it not physically separated from M1? This is what you have to observe. This is what you have to decide. अगर M2 M1 को फिजिकली टच नहीं कर रहा है तो वो उसके ऊपर फोर्स नहीं लगा रहा है. केवल आंख खोल के देखना है. मुझे दिखाई दे रहा है, कांटेक्ट नहीं है, देयरफॉर फोर्स पॉसिबल नहीं है. आई विल नाउ आस्क द क्वेश्चन अगेन. इज कैपिटल M अप्लाइंग ए फोर्स ऑन M1? Is capital M applying a force on M1? Is capital M applying a force on M2? Is capital M applying a force on M2? Is the pulley applying a force on M1? Is the round pulley applying a force on M1? Is the round pulley applying a force on capital M? Is the round pulley applying a force on capital M? Is the floor applying a force on M1? Is the floor applying a force on M1? हार्दिक, हार्दिक, ये M1 टच कर रहा है फ्लोर को, तेरे को दिखाई दे रहा है ऐसा क्या? हार्दिक, ये ब्लॉक M1 जमीन को टच कर रहा है. जमीन, फ्लोर का मतलब जमीन होता है. नीचे, नीचे जो सीधी लाइन बनी है, M1 टच कर रहा है उसको. कैन यू सी दिस? Can you actually see this guy touching this guy? दिखाई दे रहा है M1, दिखाई दे रहा है M1 टच कर रहा है फ्लोर को. हार्दिक, नॉट टचिंग का मतलब नो फोर्स. नॉट टचिंग, नो फोर्स. प्लीज डोंट यूज वर्ड्स इनडायरेक्टली, विथ अ रोप. कुछ नहीं ये यूज करना है. नो फिजिकल कॉन्टैक्ट, नो फोर्स. ओके, राइट. वेरी वेरी सिंपल. ऑब्जर्वेशन, केवल देखना है, देख के बोलना है. ओके. Now I'm going to ask you a series of questions. I am going to ask you a series of questions. Question number 1. M1, M2, external agent connected by a string. This is the floor. All answers in yes and no, please. All answers in yes and no. Is the floor applying a force on M1? Is the floor applying a force on M1? Right? What kind of force? What is the direction of force? What is the magnitude of force? ये बाद की बातें हैं. अभी मेरे को उससे कोई मतलब नहीं है. Right? We are not bothered with that right now. Just whether there is a force between these two objects or not. Floor is applying a force on M1. Floor is applying a force on M2. External agent is applying a force on M1. सोच के बोलना है. External agent is applying a force on M1. External agent is applying a force on M1. External agent जो arrow F बना के रखा है, this is an external agent. अगर आपको arrow F दिखाई देगा, that is an external agent. So this is an external agent. कोई तो खींच रहा है उसको, कोई तो M2 को खींच रहा है. जो आदमी M2 को खींच रहा है, वो M1 के ऊपर फोर्स लगा रहा है क्या? Is the external agent applying a force on M1? Very good. Excellent. Yes, that is what I wanted to. That is what I wanted to. The string is not an external agent, Radhika. इसीलिए string लिखा है ना वहाँ पे मैंने. So external agent is applying a force only on M2. It is not applying a force on M1. String is applying a force on both M1 and M2. Yes or no? String is applying a force both on M1 and M2. Yes, yes. That's good. Good. Very nice. Excellent. Next. आप बताओ ना उत्कर्ष, मेरे को आपको दिखाई दे रहा था कैपिटल एफ टच कर रहा था M1 को. Was capital F arrow touching M1? Your answer is no. Chalo, once again. Is Earth applying a force on small m? Is the Earth applying a force on small m? Remember that by Earth, I don't mean the floor. Floor is a separate object. Earth is a separate object. Earth is a round ball of rock, 6,400 kilometers in radius. Is the Earth applying a force on M? Yes, it is. Yes, it is. Is the floor applying a force on small m? Is the floor applying a force on small m? Is the Earth applying a force on capital M? Is the Earth applying a force on capital M? Yes, good. Yes. Good. Very nice. So now I think you have the hang of this. So अगल हो गया है क्या एक और? ट्रिकी हो ही नहीं सकता, या तो उसको टच कर रहा है या उसको नहीं टच कर रहा है. ट्रिकी कहाँ से हो जाएगा? ग्रेविटी बोलते हैं प्रसन्ना उसको. ग्रेविटी नाम सुना है कभी ग्रेविटी का? अच्छा, सुना है क्या? हाँ, तो ग्रेविटेशनल फोर्स लगा रहा है अब तो उसके. मैग्नेट्स अभी हमारे स्कोप में नहीं है, अभी हम केवल मैकेनिक्स पढ़ रहे हैं. अभी बोला ना मैंने, ये एक बार ये समझ में आ जाएगा तो बाद में फिर मैग्नेट भी समझ में आएगा. सो मैग्नीट्यूड मैग्नीट्यूड एंड डायरेक्शन ऑफ फोर्सेस. चलो भाई, अब ये देखो, बहुत इंपॉर्टेंट है. वंस अगेन, एक मिनट रुको जरा, मैं पानी पी लूं. So this is the most important bit. This is what is going to help you. Uh, no, M1 and M2 do not apply gravitational force on each other. And please be very clear about this. Gravitational force can only be applied by the Earth, nothing else. Okay? तो ये वाले केस में अभी जो मैंने आपको बताया था, ये वाले केस में M and M are not applying a gravitational force on each other. They are not applying a gravitational force on each other. It is something else. I will tell you what it is. Okay. So number one is the Earth. This is what you are going to use in numericals. What you are going to use solve problems. So it is imperative that you understand what I am saying here. Earth applies a force which must have a magnitude and which must have a direction. So the magnitude of the force is always mass of this system into G. Again, this G is the same as before. So I will always take G as 10. You will take G as 9.8 if you are solving a problem from a textbook, unless it is given in the textbook. The value of G is 10. Most of the cases here, we will keep G as it is. तो हम G को G रखेंगे, ठीक है ना, उसकी वैल्यू डालेंगे ही नहीं कभी. अनीश जो मैंने बोला उसको आप समझने की कोशिश करें प्लीज. I think I'm using clear words. Gravitational force is something which can only be applied by the earth, right? Is that understood? आ रहा है समझ में जो मैंने बोला? Gravitational force can only be applied by the earth on a system, nothing else. So the magnitude of this gravitational force is mass of your chosen system into G, and the direction of this force, very important, the direction of this force is always towards the center of the earth. And for all practical purposes for us, it will be downwards, vertically downwards. Okay? And it turns out that we know the value of force. We know the value of force only for Earth. मतलब कि Earth एक ऐसा ऑब्जेक्ट है सराउंडिंग में जिसकी वजह से हमें फोर्स का मैग्नीट्यूड और डायरेक्शन दोनों मालूम. नेक्स्ट. Now, we must be absolutely clear what we mean by surface. So, when I have drawn this diagram, okay, and I asked you the question, is capital M applying a force on small m? Absolutely right. You said yes. All of you said yes. Source of confusion, like Anish asked, is this force the gravitational force? The answer is no. In reality, of course, there is a gravitational force between M and M, but this force is so insignificant, so small. The force that you are applying on your pen, the gravitational force you are applying on your pen is so small that it really does not play any role in the big picture. So we will never say that the force applied by M, by capital M on M is gravitational. In fact, when I choose small m as a system, I will even not say that capital M is applying a force on small m. Please again listen to me very carefully. If I choose small m as a system, I will not even say that capital M is applying a force on small m. I will say that the surface of capital M, sorry, is applying a force, on small m, right? तो अगर मैं m के ऊपर स्मॉल m के ऊपर फोर्सेस निकालना चाहता हूं तो मैं बाउंड्री बनाऊंगा, जैसे मैंने वो ग्रीन बाउंड्री बनाई है। इस बाउंड्री को जो टच कर रहा है वो m के ऊपर फोर्स लगा सकता है, और इस बाउंड्री को जो टच कर रहा है वो है सरफेस ऑफ कैपिटल M, right? Okay, so if two objects are in contact with each other, then they will apply a force on each other, and the force will be due to that of a surface in contact. Similarly, if I were to ask you, okay, so another question coming up. How many surfaces are applying a force on capital M? Please type the number. How many surfaces are applying a force on capital M? Please tell me the number. How many surfaces are applying a force on capital M? How many surfaces are applying a force on capital M? Capital M की बात कर रहा हूं. How many surfaces are applying a force on capital M? So to do that, you draw a boundary like this. This is the boundary of capital M. How many surfaces touching this red surface? How many surfaces touching this red line? Two, right? The surface of small m, यहाँ पे, and the surface of the floor, right? Like I said, observation. You don't have to think. कुछ सोचना ही नहीं है इसमें. केवल देखना है, आँख खोल के दिखाई दे रहा है, हाँ ये इसको छू रहा है, फोर्स लगा रहा है, नहीं छू रहा है, नहीं फोर्स लगा रहा है, कहानी खत्म. जो एक ऑब्जेक्ट है बिना छुए फोर्स लगा सकता है वो अर्थ है. Okay? So what is the force applied by the surface on a system? Well, the force applied by the surface on a system is very, very complicated. Very, very complicated. Your pen is there on the surface, extremely complicated situation. There's billions of atoms interacting with billions of other atoms. Billions of atoms of the pen interacting with billions of atoms of the table. Okay, that is what is producing the force between two surfaces, not gravity. Gravity has got nothing to do with it. So how do I deal with this complicated force? Well, I know that I can take components of a vector, right? So if this is sort of one surface and this is another surface, maybe this is the pen and this is the table, right? So what force is the table applying on the pen? Extremely complicated to think about. So what I do is that I say that, look, I don't know what the force by the table on the pen is. Let's say that it is here and I don't know the magnitude. मेरे को नहीं मालूम कितना है. ठीक है ना? मेरे को मालूम नहीं है magnitude क्या है, direction क्या है. तो मैं क्या करूंगा, ये जो force है इसके मैं दो component ले लूंगा. एक perpendicular to the surface और एक parallel to the surface. Right? So this is the complicated force which is acting, the complicated unknown force, which is acting between the surfaces of the pen and the table. I will take two components of this force. One component will be perpendicular to the surfaces and the other component will be parallel to the surfaces. What is another word for perpendicular? Anybody remembers? Perpendicular के लिए और कोई word होता है? Synonym of perpendicular is normal. So we will say that the surface applies two forces. One is the normal reaction. Okay, and the other is friction. Now I'm saying two forces, in reality it is only one force. It is called the contact force. It has two components. One is the normal reaction and the other is the friction force. So the normal reaction is always perpendicular to the surface. Okay, so I want to tell you the magnitude of the normal reaction and I want to tell you the direction of the normal reaction. So the magnitude of normal reaction is unknown. Never ever, please never tell me that the normal reaction between these two surfaces is this just by looking at the problem. Never ever tell me that. Normal reaction has to be worked out. Okay. In some cases, normal sorry, normal reaction is uh, normal reaction is something which is having a magnitude which is unknown. Okay. Normal reaction का magnitude n है, unknown है, or I will take it as R. Normal reaction is either n or R. The direction, however, is known. The direction is perpendicular to the interacting surfaces. Okay, the direction of the normal reaction is perpendicular to the interacting surfaces. मैं सब एक साथ कराना चाह रहा था, चलो अभी टाइम हो गया. I'll tomorrow, नहीं, next Wednesday को I'll continue with this. Wednesday ko I'll tell you the forces again out of due to all the 5 objects in the surrounding, and we will discuss the most important thing, single most important thing in physics called the free body diagram. आपको lecture 1 already मैं दे चुका हूँ. ये lecture 1 को please read the lecture 1 and then we'll discuss. Right, we'll come to the class. ठीक है, चलो, I'll see you on Wednesday. हाँ, लेक्चर 2 भेजता हूँ. वो पूरा एक्चुअली कंपाइल करके भेजना है, मैं भूल गया. हाँ हाँ, सब भेज दो. Yes, yes, I will send the slide. Yes, yes. आज ज्यादा चिल्ला लिया भाई, गला एकदम दर्द हो रहा है. अगली बार याद दिला देना मेरे को, चिल्लाना नहीं है. चलो, ओके, बाय बाय.